Hello everyone, welcome back. Today we'll be discussing the third unit that is measurement and analysis of data. Unit 3 will be discussed in two parts, part 1 and part 2. This is part 1. So this is today's content. So let's get started. The first point is 3.1 scale of measurement. So first let's break it down by understanding the two words scale and measurement. So what is measurement? Measurement is about collecting information or data to understand something. Think of it as finding out how much, how many, or what kind of data or information. For example, measuring how tall a student is, the height, or counting how many questions a student answered correctly. So it's like using a ruler or a stopwatch or even a checklist to gather information. It's a way of gathering information. Next, what is scale? Scale is about a type or label of the information you are collecting. It tells you how to organize and interpret the data. For example, if you are collecting information about students, right? You are collecting information. So you are just listing categories. For example, this favorite food, colors, example, or are you ranking them like best to worst? It can be you are ranking them best to worst, or just measuring something that have a 0 point. For example, time spent or time tasked. So this all are the examples. So putting them together, scale of measurement. So when you combine measurement, that means gathering data, with a scale, that means a type of data, you get the scale of measurement. So this helps you to know how to organize the information and what kind of analysis or interpretation you can do with it. So therefore, the scale of measurement is a way to describe how we organize and label data or information in a meaningful way. And it's important because it has or it helps us to understand how to use and interpret the data. So there are four scale of measurement: nominal, ordinal, interval, and ratio. So now let's see each scale or the level of measurement. First is, what is nominal scale? The definition: nominal scale is the lower or the lowest level of measurement. It categorizes data without any order or ranking. Numbers or labels are used solely for identification purpose. In simple words, nominal scale is the most basic way to organize data. It simply puts things into category or groups without any order or ranking. The numbers or labels you might assign are just for identification, not for any kind of comparison. For example, if you are using 1, 2, 3, 4, it's just for labeling. We are not, mm, ranking them. Next is characteristics. First, uh, categorical data. The data here is divided into distinct categories. The next is no order. There is no inherent order or ranking among the categories. And the third one is qualitative nature. The scale is qualitative, meaning it describes the characteristic rather than numerical values. That means it describes the emotions, the behaviors we say, right? For example, gender. So we are categorizing in gender, male, female, transgender, etc. Or we are even categorizing the data in some hair color that has black color, brown color, bronze, etc. Or we can even use the data together and we organize it in the category of favorite fruit. So one or how many persons like apple, something like that. Apple, banana, oranges, etc. The next is ordinal scale. So what is ordinal scale? The ordinal scale ranks data in a meaningful order, but the interval between ranks are necessarily equal. It allows for comparison but doesn't quantify the differences between ranks. In simple words, ordinal scale is used to rank things in a specific order like first, second, third. It tells you who is ahead or behind, but it will not tell you how much better or worst. Example, survey asking people to rate their satisfaction like very happy, happy, neutral, unhappy. So You know very happy is better than happy, but you don't know how exactly the happier they are. So the characteristics are, first is ordered categories. That means data can be rank or order. For example, survey responses like excellent, good, fair, poor. So these are the categorizing. Next point is unequal interval. That means the difference between rank is not consistent or measurable. And the third point is qualitative and quantitative properties. That means the data here combines categories data with some quantitative aspects. Example, class ranks like first, second, third, combine the order with the number. Right? We are ordering, but we are also using the numbers. For examples, customer satisfaction rating, very satisfied 1, unsatisfied 2, neutral 3, satisfied 4, and very unsatisfied or very satisfied 5. For example, customer satisfaction ratings, very unsatisfied 1, unsatisfied 2, neutral 3, satisfied 4, and very satisfied 5. So why it's ordinal? Because the ranking are ranked in order from least satisfied to most satisfied, but the gap between neutral and satisfied may not be the same as the between unsatisfied and neutral. Next example, education level, high school 1, bachelor degree 2, master's degree 3. So why again it's ordinal? Because the level here has a clear order, higher education level rank above lower ones, but the difference in effort or time between a bachelor rank and a master rank is not specifically measured. So it's a ordinal. And let's see the next interval scale. The interval scale is a measurement scale that ranks data in a meaningful order with equal interval between values, but it doesn't have a true 0 point. This allows for the comparison of difference between values but not the ratio of values. In simple words, an interval scale organizes data in a rank order, but the gaps between the values are equal and consistent. It's not like the ordinal one, but the gaps have an equal value. However, it doesn't have a true 0. That means 0 doesn't meaning nothing. There is some value of 0. If you say 0, for example, if I have 0 money, that means I don't have any money, right? But here when we use in our interval scale, the 0 has some meaning. It doesn't mean it doesn't has nothing. So let's see some characteristics. Ordered values. The first is ordered value. Data can be ordered from lowest to highest. We can order it. Example, 10 degrees Celsius is lower than 20 degrees Celsius. 20 degrees Celsius is lower than 30 degrees Celsius. Example. Next point, equal intervals. That means the difference between any two values or adjacent values is the same, allowing for measuring comparison. For example, the gap between 10 degrees Celsius and 20 degrees Celsius is same as between 20 degrees Celsius and 30 degrees Celsius. And the third point is no true 0 value. That means the 0 point doesn't indicate the absence of the characteristic being measured. It's just arbitrary. That means 0 degrees Celsius doesn't mean no temperature, right? So it's just a point on the scale. Some examples, interval scales can be used in temperature, IQ scores, calendar years. So these are the three areas where we can use interval scales. Here is a bar graph representing the temperature in Celsius, which is an example of an interval scale. The difference between each temperature, for example 10 degrees Celsius to 20 degrees Celsius are equal, but the 0.0 degrees Celsius doesn't represent the absence of temperature. There is a temperature, but it's 0 degrees Celsius. So next scale, ratio. Now let's see the definition. The ratio scale is the highest level of measurement that ranks data in a meaningful order with equal intervals and a true 0 point. This allows for the comparison of both differences and ratio between the values. In simple words, ratio scale is the most advanced way to measure data. It ranks things in order wise with equal gaps between the values, and it also has true 0 that means nothing or none. 0 means there is nothing or there is none. It doesn't mean, for example, in um, in the previous scale, interval scale, 0 means 0 degrees Celsius means it has some value, right? But here in ratio, 0 means it's the true meaning. 0 means nothing or none. Now let's see some characteristics. Ordered value. Data can be ranked from lowest to highest. That means we can rank them. For example, first place, second place, third place. Alright, the second point, equal intervals. That means the difference between any two adjacent values is consistent and meaningful. For example, the difference between 10 kg and 20 kg is the same as between 20 kg and 30 kg. The third point is true 0 point. The true 0 point, that means the 0 values indicates the complete absence of the characteristic being measured. That means 0 means the complete absence of what being measured. For example, 0 meter means no length at all and 0 kg means no weight. So some more examples where ratio can be used are height, weight, income, ratio scale in simple terms. A ratio scale measures things where there are equal intervals between values. That means 1, 2, 3 examples. So it has a through 0 meaning. 0 represents nothing or none. Example, weights. 0 kg means no kg at all. Someone weighing 60 kg is twice as heavy as someone weighing 30 kgs. We can compare. Another example of money. $0 means no money. If you have $100 and your friend has $50, that means you have twice as much money as your friend. So we can compare this as well. Let's see one graphic representation of ratio scale. The scenario is you are measuring heights of 5 students. First student is 120 centimeters. The second is 150 centimeter. Third student 140 centimeter. The fourth 160 centimeter. The last Edward has 130 centimeter. So this is all in one box. So let's see some differences at a glance. Nominal means only for grouping, no ranking, no calculating. The ordinal is you can rank items, but the difference between ranks is not consistent. It's not equal. Interval means you can measure and compare differences, but there is no absolute zero. That means the meaning of zero doesn't mean zero. The ratio is the most precise with measurable differences and a true zero, allowing full calculation. That means twice as much. Example. So easy way to remember is nominal names only, ordinal order matters but the gaps doesn't, interval equal gaps but no true zero, and the ratio is equal gaps with a true zero meaning. Next subpoint 3.2, organization of data. That means array and group distribution. So let's first understand what is organization of data. Organization of data is the process of arranging and structuring raw, unprocessed information into a clear and logical format. It helps to make data easier to understand, to analyze and use for decision making or further analysis. In simple terms, it's like tidying up a messy room. Everything gets sorted into proper place so you can find and use it effectively. What is array? Array is a linear data structure that stores a collection of items of the same data type in contiguous memory location. Or an array is a simple arrangement of data points in either ascending or descending order. This method allows for easy identification of the minimal to maximum and overall distribution of values within a dataset. In simple terms, array is a way of organizing data in a straight line, like a row or list where all the items are of the same type, like numbers, letters, or names. All the items are sorted one after another, so they are easy to access. Now let's see some characteristics. Sorted order. Data is organized from lower to highest or vice versa, making it easier to analyze. For example, a list of test score sorted from the lowest to highest. The next point is simplicity. Provides a clear view of individual data points without any aggregation. For example, you see each student's score separately, not average or combined. Alright. The next point is fixed size. The size of an array is defined at the time of its creation and cannot be changed dynamically. That means in practice, let's say you have a group of 10 students and you want to create an array of their test scores. So the row score, that means unorganized, is 45, 60, 55, 70, 40, 65, 50, 60, 75 and 55. So now we have done in arrange or organize in array, that means in ascending order. So this is the ascending order we have arranged. Now after arranging this marks or the scores, we can quickly find the average. We can even find the median as well. Again, we can spot the trends, like most students score between 50 to 60. So this is the benefits of arranging the row data in ascending or descending order. It means in an array. So the next is grouped distribution. Grouped distribution is a way to organize large set of data by grouping the values into categories or intervals, that means classes. Instead of listing every single values, we count how many fall into each group and present it in a table or chart. That makes it easier to see patterns or trends in the data. So why we use grouped data? When there is too much of data, listing every single value can be overwhelming. So grouping helps simplify the data, making it easier to understand and analyze. The simple example is, imagine you are a special educator tracking how many minutes your students spend reading in a week. So here's the data, 5, 10, 15, 20 and all. So the first step will be creating the group. Alright, the intervals, the group. Instead of listing each number, so we will group the data into ranges like 0 to 10 minutes, 11 to 20 minutes, 21 to 30 minutes, so on. So the next step would be counting how many falls into each group. 0 to 10 minutes, how many students read for 0 to 10 minutes, like that. So check how many students reading times falling into each range. For example, 0 to 10 it's 4 students, 10 to 20 minutes is 4 students and 21 to 30 minutes is 2 students. So the last step, creating a table, that means grouped distribution table. So this is the table. Why this is helpful? So you can quickly see the most students read for 0 to 20 minutes. It's easier to analyze the pattern compared to looking at the raw data. So if we have arranged this data in array, so it could not be so much easy for us to quickly check like how many students read for how many more minutes, something like that. So you can use this to make graphs, example bar charts. In short, grouped distribution helps to organize and simplify large set of data into meaningful chunks. The other 3 points of this unit will be discussed in other two part 2 video. So that's all for today. Thank you so much for watching. If you like it and it's beneficial to you, give a thumbs up and so that you can contribute to my work. See you in the next part. Till then,